Welcome to Module 5, Lesson 19, Understanding Variability when Estimating a Population Proportion. Okay, and that idea, that concept of proportion is going to be very, very important. The work we do in this lesson will look very, very familiar to you. I'm not sure they don't make any reference to us having broached this subject beforehand, but that's okay. It's nice to approach something as it's new and maybe in a different way. We are going to compare what we do here with this idea of proportions to what we've been working with the last few lessons, the prior lessons, which dealt with sample mean. Okay, remember that sample mean we worked with, the average of a population sample or sample from a population, okay? And we talked about variability, and you understand that rule. As the sample size increased, the variability decreased. You will see that play out similarly when we talk about proportions, okay? Okay, so a few things we wanted to talk about. So, data used to calculate a proportion. Okay, so we're going to talk about a few things here. We're going to discuss some statistical questions. All right, coming up, and we're going to look at a few different things. Okay, so first of all, we're going to look at the data used to calculate a proportion. We are going to look at data used to determine a mean. And then we have statistical questions right here. Okay, so data used to calculate a proportion. So some examples of that would be, what proportion of gym members. So what proportion of gym members would be female. Okay, gym members would be female. And if you are familiar with going to a gym, you may have one opinion, and if you're not so familiar with the gym, you might have another opinion. Okay, because if you just want to, we know about the population of the United States is 50-50, just about male and female. So to say 50% would probably be a good guess. Now, maybe you go to a certain gym, and certain gyms are real heavy with women going in the morning, men not necessarily there as much in the morning, men more at night. But then again, there's a pretty big population of women there at night. All right, so they tend to be a lot of step classes and aerobics classes in the earlier hours. And most of those classes are populated with women. So anyway, that's just an example of proportion. Okay, so what proportion, and again, that proportion could be represented as a decimal, a fraction, a percentage. Okay, other ones that we've looked at that have dealt with data used to determine a mean. Again, was back to the gym again. We talked about the mean time spent at the gym. If you remember that example, we saw it was in the population we had 800. We had about 52 minutes or so. And again, that's just for this example, and where this data was pulled from, I have no idea. Could have been pulled out of someone's hat for all I know. But mean time spent at the gym is and again, this is numerical data. This is data that we looked up. We looked in terms of minutes, okay, and then these minutes were averaged to get a mean. All right, we are not using necessarily any numerical data up here, okay, when you're calculating a proportion in the sense, well, you are. You have numbers truly, 45 female and 25 male, let's say, and then we can create a proportion. But here we are with that data that we collect, we are crunching it, and it is we're creating a mean out of the numbers that we collected. Okay, I know it's a very subtle difference, important. If it's clear as mud now, hopefully it gets as clear as maybe kind of muddy water. All right, now we're going to look at a couple of statistical questions here on the following page, and here are some of the things I want you to, we're going to consider. We're going to consider what data will be collected. Okay, we have a statistical question. We'll try to determine what data will be collected. And next, what will be done with the data? Okay, what will be done with the data? And that's what kind of distinguishes this idea of a proportion and a mean. Okay, our first question to look at is this one. How many hours of sleep do 7th graders get on a night in which there is school the next day? And again, we're looking at the data to be collected and then what we're going to do with that data. Okay, so I'll cut right to this one, and then maybe the next few we could talk about. I could have you think a little bit about, and then come back and see the answer. So, in this case, I mean, the data to be collected is going to be the number of hours, okay, that students in this sample sleep. All right, how many hours? Okay, so we're going to get how many hours of sleep do they get? Okay, that's the data to be collected. We're going to collect this from this group of 7th graders. There's no number here of how many we're talking about. Okay, but data would be these. That's the data we're going to collect from everyone. All right. Now, in terms of what we're going to do with that data, this would be numerical data, okay, because it's going to be numerical data because there's going to be a number attached to it. Okay, so for example, how many hours of sleep? 8 hours, 7 hours, and on and on and on. Okay, so it's going to be collected. It's going to be in hours, and then what we're going to do with that is we are going to get a mean value. Okay, we're going to get a mean value, all right, or an average, and then we're going to find that. That's how we'd answer that statistical question. So in this case, you can see that this is a place where we're talking about gathering a mean. Okay, so the next question, question 2 here, is what proportion, hint, 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 okay, what proportion of the students in our school participate in band or orchestra? Well, this sounds very familiar, doesn't it? Okay, well, I mean, right away you can see there's a proportion here, so we know it's going to be a proportional question, but in terms of the data that we're going to collect, okay, the data that we're going to collect, we are going to collect data of the number of people. We're going to ask them. So we're going to ask students, do you perform, or do you participate in band or orchestra? Okay, in band or orchestra, and we're going to ask that question to them. We're not going to ask them how many hours they sleep. We're just going to ask them a question that's going to require an answer such as yes, no, or band, orchestra. So it's not going to be numbers that we're collecting. So this is not numerical data. So it's not numerical data. So there won't be any mean taken. Boy, spelling problem here. Numerical data. Okay, so it's not numerical data. So we're just going to collect answers. Okay, answers such as band and orchestra. Okay, those are good. That's the data we're going to be getting. We're going to be getting those. Okay, so then what we're going to do is then we're going to actually find a proportion. Okay, and that proportion is going to be so many out of so many. So if we have 14 out of 30 in band, okay, and then 16 out of 30 in orchestra, whatever, and these numbers could be whatever. I'm just making these up, and then we can come up with a certain either decimal value or percentage value here. Okay, so this is a proportion question, and again, it gave it away right there. Okay, next one. Question 3 here. What is the typical weight of a backpack for students at school? Okay, typical weight. We can see right away in this question, typical weight. Now that is going to have a numerical value attached to it. Okay, it's going to have a numerical value attached to it. So we're going to ask all the students and same students at our, well, maybe not same students, but students at our school. How much does your backpack weigh? Okay, or we're not going to ask them. Well, maybe we'll have a little scale, scale to take around with us. They have great scales with hooks on them, like you're weighing a fish, for example. We could take those around. It might be fun, actually, fun project to do. Hang it from the scale and see how many pounds or how many kilograms their backpack is. So with the data, we're going to be collecting this data. So again, this, just like that first example here, this is a numerical data, okay, because the data we collect is actually going to be a number, and that's going to be either something, pounds or kilograms, okay? All right, so what we're going to do with that is we're going to actually average those up and get a mean value again, okay? So in terms of this statistical question, we are going to be generating a mean from this numerical data that we collected, okay? Finally, okay, I'm sorry I hit the wrong button there. Next, final one, question 4. What is the likelihood that voters in a certain city will vote for building a new high school? Okay, here we go. Keyword here would be likelihood. How likely are they? Well, they're about 50% likely, 30% likely, it seems. Okay, very likely, not so likely, unlikely. Okay, so it works on that scale. So in that case, we're collecting. It's not numerical again. All right, there's no numerical value. All right, we're going to ask them, will you vote for building a new high school? And their answer, their data, is going to be yes or no. Okay, in this case, it's going to be yes. Sorry, I paused again. I'm not sure where I was. So I just did question 4. I'm not sure if I did that at all with you. Anyway, it was the likelihood that voters in a certain city would vote for building a new high school, and that word likelihood told us that it's not necessarily numerical data that we're collecting. Okay, we are collecting we're collecting responses, which are yes or no or could be undecided, for example. And then what we'll do with that data, then we will go ahead and come up with a proportion of those people that voted, in this case, yes, okay, because our question was what is the likelihood that they will vote yes for a new high school, all right? And so that is a proportion. Very, very important in your statistical future to understand the difference between these two when numerical data is collected, okay, versus when it's not collected, okay, and what you can actually do with that data. You can't find a mean from data where there is really no numerical value to that data. Now, in the end of it all, as you can see here, it's numerical. This mean value is an average, okay, and the proportion is a percentage, okay, in a sense. So, there's numbers involved, of course, okay, but when it comes to the data that's collected, it is either numerical or not numerical, that data. Okay, so in a previous lesson, we selected several random samples from population. Okay, we did this quite a few times. Hopefully that is truly embedded in your memory. We recorded values of a numerical variable. We then collected the mean for each sample. We saw that there was variability in sample means. Okay, so very often, again, that variability idea, very, very important to the world of statistics. It is something we cannot avoid, but we can try to control it. Okay, can kind of control it. So, and we created a distribution of those sample means to better see the sampling variability. So we made our dot plots and we looked at them and we saw what it actually looks like and how variable our means were. Okay, we then considered larger samples and saw that the variability, again, this is a major point, and I think one we've stressed quite a bit, is that the larger the variability decreased when the sample size increased. All right. So in this lesson, we're going to use a similar process, but we're just going to be focused on proportions this time. Okay, so we're going to look at example 1 here, sample proportion. All right, so again, we're not doing this in class, but if we were in class, I'd put you in groups, give you guys all a bag that contains colored cubes or something of that nature. Okay, some of which are red. Okay, and those red is what we are focused on in this this sample here. Pretty much this whole lesson actually. So, with your classmates, you're going to build a distribution of sample proportions. So we're going to do very, very much what we did and have done in past lessons. Very similar. Again, I am just taking some sample data. I am not pulling things out of a hat this time, but I'm going to take the shortcut, all right, today. So, firstly, what we would do, and we would go ahead and pick a sample of 10, all right? So, our sample size, and if you remember how to write this, we wrote this as our n equals 10, okay? And remember that n, that small or that lowercase n, stands for sample, and so our sample size is 10, all right? So what is our proportion? B asks us here, what is our proportion? If we go and look at it, we can see that there were three reds over 10 that we pulled. Okay, and again, this is without replacement. Okay, so we're not looking for probability here. We are just pulling a sample. Okay, pulling a sample. So there were 3 out of 10, or 0.3. And again, they don't use percentage here, but you and I might say 30%. Okay, so this value. Okay, so this value of 0.3 is what we call the sample proportion. Okay, the sample proportion, as we know, is found by dividing the number of successes. We talked about this before. Okay, number of successes divided by the total number of observations. Okay, so again, 3 divided by 10 was our 0.3. Okay, again, so if we're in a classroom, we would write our sample proportion on a Post-it note. This would be really fun, and I'd have, this number line drawn on a whiteboard, and you guys could come up and you could place your note above the value on the number line that corresponds to your sample proportion. And so, of course, when doing a sample, using a sample size of 10, it's really nice and neat. Everything is nice and even and would fit directly over those values on this number line here. Okay, so here, if I went ahead and again I took this from my teacher's guide here, very, very helpful in this case. And if I went ahead and we had a group of 60 students, this dot plot, this distribution, this sampling distribution dot plot would look something maybe like this. Okay, our small class of 14, of course, would not look like this, but it might have a similar variability, and you can see the variability here. Okay, and it is quite so. If we describe the shape of this distribution, it's pretty symmetrical in the sense that we could, if we drew a line maybe right here, okay, it's about the same on this side as on, well, actually if we drew a line right here, okay, kind of same there as it is over here, okay, so somewhat symmetrical. I guess I can put that down, symmetrical, all right. All right, and a lot of it, but a lot of the distribution is pretty much clustered around just right in this area here, okay, and more so, if we took an average, probably a mean, it'd be right about in there, okay. All right, so clustered. So it clustered around maybe 0.4 or so. Okay. All right, so the variability, if we were going to go ahead and here E, it asks us to go ahead and describe the variability of this sample, the sample proportions. We see a spread goes from 0.1 all the way down here. So we have this kind of this range. It's quite a wide. It's kind of a wide variability, so wide variability, but an obvious cluster. Okay, obvious cluster. It is variable. There's only one value here, one here, there's 3 here, 2 here, but most of them are, of course, right in this area here. Alrighty. Okay, so I'm going to go ahead and put our distribution in here again and wait for that to happen. And we'll answer these last 2 questions here, F and G. So F says here, what do you think is the population proportion? Okay, again, in this population proportion, that's the total. The population here is the total of the cubes in the bags, or I should just put total of cubes in bag. And we don't know how many there are. I haven't told you that yet. Okay, total cubes in the bag. What do you think the population proportion, and again, we're talking about red now. Okay, we're talking about red. What do you think that red proportion might be? And again, you're going to base on this distribution down here. Okay, so what might you say? And I'm not sure what you're saying, but I would say probably right there. Okay, got some 3s, got some 5s, and all this other stuff, probably maybe a little bit, I don't even know, probably just about that. Probably say our red proportion is probably about 0.4. Okay, that seems pretty, like a pretty good guess. Okay, how confident are we? Well, here's the thing. We obviously have this going for us, okay? But it's 30 and N was only 10. Okay, it's pretty small sample size. Pretty small sample size. How confident? Not exactly entirely confident due to the variability. So this variability makes me uneasy, let's say. Okay, it makes me uneasy. All right, I have this here, all that, and I have this here. Okay, and again, those are just for 7 out of 30, but still it exists. Okay, so the variability makes me uneasy. All right. And of course, you probably guessed it. We are going to increase our sample size. So what do you think would happen to the sampling distribution if everyone in the class took a random sample of 30 cubes? Okay, so now our sample size is upped, okay, increased threefold, okay, threefold. So to help answer this question, we are going to repeat that. Again, of course, if you want to go ahead and do this yourself at home, again, like I said, those are very, very interesting things to do and lots of fun and revealing. But if that's not the case, we'll just go ahead and you can let me just kind of cheat in a sense. Just get some numbers from some other source. Somebody did this somewhere in the world, so we're going to borrow their work, okay? So here we go. Let's see what this is the first outcome. All right, so if we take a look at that, I'm really getting chintzy now here, just using first letters. All right, so we have, the first thing we're going to figure out here is what is the proportion of the red cubes in our first sample of 30. Why don't I just pause here and have you do something this lesson. Go ahead and calculate the proportion and come on back. Okay, well hopefully most of you, if not all of you, did that. So if we look, we highlight our reds that we picked, and again we're proportion of red cubes, because red is what we are concerned with here. and that was 11 out of 30. And hopefully you got something like that, 0.367. That would be the proportion of our red cubes in this sample. Okay, so as we did last time, we're not going to use Post-it notes because you are there and I am here. So I will go ahead and populate my a sample number line with some data, okay, with some data points, and they are going to be from the teacher's guide, and here's what that looks like. Okay, again, drawing my number line again, the same number line as I had before, right, and populating that number line now. Very, very, very obvious. There's some obvious similarities, as you can see. But in this case, if we were going to go ahead and describe the shape of this distribution, this shape in this sense is more like a kind of mound-like. You can see this mound here that is developed. And look at that right there. It's kind of a mound. It's you can see there's, I guess I'm probably going to answer the next question, so why don't I just go to that question, all right? And here we go. So describe the variability in the sample proportions. So, okay, now we're talking about variability here. If I was to go ahead and describe the variability, I'm going to say it's, it's less than when we took samples of 10. Okay, that's for sure. I mean, there's still variability, but, I mean, it just ranges from, I don't know what this is, probably right here, maybe 0.26 to 0.52, all right? Not as drastic as we had 0.1 to 0.7 last time, and a major cluster right around here, of course, again, all right? Real cluster getting closer and closer to that middle right there, 4, okay? So now if we ask ourselves, based on this population distribution here, what do we think the population proportion is? I'm not sure I would change my mind, okay? I'm still thinking it is 0.4, all right? So that hasn't changed, despite the fact that my sample size has changed. But the only thing that has changed is the variability. And along with that variability being less, I can say I feel more confident than before, okay? More confident than when n equal 10, okay? N equal 10. So I'd say I'm rather confident, all right? Rather confident here that 0.4 is going to be darn close, all right? And this last question here asks, if you were taking a random sample of 30 cubes and determine the proportion that was red, do you think your sample proportion will be within 0.05 of the population proportion? Okay, and what does that 0.05 mean? Well, that means, of course, 5%, right? If we were to be within 0.05 here, and our estimate is 0.4, we'd have to be between 0.35 to 0.45, okay? All right, so that's what the actual sample population, the population proportion could be if we are going to be that confident. Now, this is a very, very important number. Again, they're not, I'm not being told here to mention that, but this 0.05 is a confidence number, and when you look at statistics later on, you can calculate what's called a p-value, all right? And that p-value is your probability value, and it's the value. So in this case, it says you are going to be within 5%. There's 5% chance that you're probably not right. You might not be right, but there's a 95% chance that you are right. In this case, there's a 95% chance that you are that close to the actual population proportion. All right, so that's 0.05, very, very important statistical proportion. Okay. So let's go ahead. We're going to go ahead and compare these two that we took. So let's go ahead and draw them. Okay, this is our first. Well, that's not our first. Actually, I started from the second one here. This is our n equals 30. And then we go ahead and draw the next one. This was the first one, actually, that we used. And that's where n equaled 10. Okay. All right, so if we look at these two, we can compare our sampling distribution based on samples of 10 to the sampling distribution based on samples of 30. Okay, so what do we say when we compare these two? They're both similarly shaped. Okay, and again, a very important statistical shape, and you will see this again later on. But there's this idea of a mound, and not necessarily here, but we also talk about something called a bell curve, which you will talk about later on in your statistical future. They're both mound-shaped, so let's just say they're both mound-shaped, clustered in the middle, clusters around 0.4. 0.4. Also, the variability of 30, where n equals 30, is less than when it was n equals 10. So you can see our variability. Let's draw that in a different color. Okay, so here's our variability here, or a range, and then you can see this one much bigger there. Okay, so our variability less where n equaled, well, just say with larger sample, because that's what we're trying to get across, and I think you've gotten that point by now. As the sample size increased from 10 to 30, describe what happened to the sampling variability. Okay, I think we just talked about that. Okay, not sure. Oh, I guess that should have gone down there, huh? Okay, all right, so next question, hypothetical question here. What do you think would happen if the sampling of what do you think would happen to the sampling variability, okay, of the sample proportions if the sample size for each sample was 50 instead of 30? Okay, and explain, and again, theoretically, not definitely, but theoretically, that variability will lessen. Okay? If you're going to have a sample size of 50, that variability should continue to get less and less and less. Okay, and that's it. We're here at the end. And here's our lesson summary. The sampling distribution of the sample proportion is a graph of the sample proportions for many different samples. Okay, that's not any groundbreaking news. The mean of the sample proportions will be approximately equal to the value of the population proportion. Well, okay, I mean, approximately, I guess, right? As the sample size increases, the sampling variability decreases, and this we have been told a number of times, but important. And again, hopefully some new vocabulary, a new idea or two in this lesson. I'm not quite sure. If you find anything that's confusing, maybe that wasn't explained in your problem sets, just let me know. I'd be glad to help out. All right, so go get to it, and see you next lesson.